Welcome. So we're going to talk about a route data miner and really how it does help you make better decisions. A little bit of background here. Bentley has been involved for over 20 years in the automation of oversized, overweight permitting and routing. We've tried to be as complete as possible in that, ensuring that everything is good with the permit administration processes, that we are doing everything possible in the routing and analysis of structures, and inclusion of all the dynamic restrictions that occur at any one point in time. As we've done that automation, though, and focused on things like getting to high levels of system issuance, there has been data that we've had, that we've used or created as part of our trip reviews that we've discarded. And as we continue to work with permit office staff and executive management at various agencies and listen to industry, we find that more and more there's a real need to have some of that information that we were discarding available and to be able to use that data in some very, very powerful ways. The Federal FAST Act that's been around here for the last year or so also makes freight planning so important with federal requirements on the use of data and plans and development of freight networks. And so we see that that can play a role in all this too, and then help guide some of our direction. A few years ago, we started the development of the Route Data Miner, made it initially available. And what we really hope to show today is that with our V5 Connect Edition release, that we're really taking it to the next level. This presentation really focuses on data, or I should probably say the power of data. I mentioned that the FAST Act has some different requirements for review. Those are good. We want to help all of our agencies comply. There's a number of us who have also read some of the books like I just popped up here, one of them Code Halos and the other Super Crunchers. And what these books really just help to understand is exactly how powerful all the data is in the world that's being collected about us nonstop. The Code Halos is the term that these authors came to talk about, all that data that really surrounds us in every bit of our being today that's being constantly collected and used in different ways. And the knowledge of exactly where we've traveled, the knowledge of our phones, knowing how many steps we've taken and where those steps were. Amazon knowing that we bought one book and that they should then, based on 40,000 other people that bought that same book, be recommending something else to us. So the more that systems are automated, the more data that can be maintained, the more different types of uses that we're able to find in all of that. For any of you who aren't aware of all of our history with the permitting and routing and the automation that we've done in the past, I'm going to take just a minute or so here and look at exactly what we do there, because it's fundamental to where we go with the data that is available and how we then mine that information. With the routing, we work with route networks, as many of you will know, based on the state data. Need to know where the roadways are, what kind of connectivity exists between the roadways, where structures are, whether we're crossing over under those, what kind of condition they're in, what kind of clearances they have, and you use all of that information to determine safe passage, a safe route to be permitted. As we're doing any of our evaluation, we're able to include in the live load bridge analysis. And so we're taking a look at the specific permit vehicle in question and all the different structures that may be crossed over, and trying to do as engineering detailed of an analysis of those structures as are possible. The analysis that we do, we are actually able to do 6 different ratings. We can look at 3 different conditions where we're loading the bridge side by side with as many of the permit vehicles as possible, and then looking at those vehicles crossing at full speed with full impact, lessening the impact, and then reducing the impact to as little as possible. And we can make those same impact kind of considerations where we go and isolate the vehicle. So the bridge analysis that's running behind the scenes is taking all of that into consideration. And then the last key pieces of data that we're using in our analysis are the temporary restrictions, the dynamic things that are happening on highways, the flood that wasn't expected, the bridge inspection that found a clearance that wasn't what it was stated in the bridge inventory, or they found a crack in a beam, and the decisions that need to be made for how we're going to go and affect travel over or under those structures, whatever the case may be. And so all of that is involved in the analysis that we're doing for every single permit application that's reviewed every single day. And that's what we've really existed on for many, many years, that we worked up the absolute greatest level of automation that we could possible for that part of the review. But now we get to today and the whole data side of this, and we're asked the questions like, how many times was a specific roadway segment traveled? What was our most traveled segment of road? Well, how many times was a specific bridge crossed over? Or show me how many times every single bridge that we have was crossed over or crossed under. And those questions can become even more complicated then when we go and add other criteria to that. Show me all that for a specific time frame. Show me all that for just a specific company, or one of that company's vehicles, or for a vehicle that's bigger than a certain width, or taller than a certain height, or heavier than a certain weight. Show that to me for a commodity of load that was being moved around. Show me that for loads that just started in a certain place and then were outbound somewhere else. So those are the questions that we're being asked right now, and for many, many years we didn't have the capability to answer those questions, but now we, I should say you, our users, definitely do. That solution is something we refer to as the Route Data Miner. If you talk to us, any of us, and for any amount of time, you'll probably just hear us talk RDM for short, but the RDM, the Route Data Miner, can definitely answer all of those questions. What we do for this process is we are, in every single request that we're evaluating as part of the permitting and routing process, we are saving information that can be used for the future. So we save data on each application, on every segment of road that was traveled, and then every bridge that was crossed over and under. And being that we keep track of the specific application and those uses, we can then tie that application ID back to just about any other parameter in the system and allow us to build up some very, very complex type of querying. Before I get into this anymore, just need to say thank you to the Maryland State Highway Administration. Maryland State Highway Administration gave us permission to use some of their data for this presentation. We could go and try and create some sample data. The problem with that is that the Route Data Miner is really able to show its capabilities when we have a good volume of data, and when that volume of data is actual real-world valid trips. And so rather than showing something that's mocked up and doesn't visually make a lot of sense, we're really grateful for being given the opportunity to use the Maryland data here. And to protect the confidentiality of specific carriers that were involved in the moves and stuff, we won't be showing any carrier names at any time. We won't be showing any specific vehicle identifiers or anything. And we're going to limit everything that we do just to the January 2017 time period. But I think we'll be able to convey the full capabilities and power of the tool based on that information. When we talk about the Route Data Miner, it's composed of three main areas. We'll see on the left-hand side a query pane. There's also a panel that we can slide up and down where we show a very dynamic, very powerful not just fixed legend, but a legend that allows us to go and manipulate exactly how we're seeing, and in many cases, what we're seeing in the data. The top right-hand side has a dynamic map result pane, and then the bottom right-hand side has our tabular data results. So we're able to do a query, and we can see that graphically as well as textually. The RDM supports 6 types of queries. So one type of query is to see the number of times that a specific bridge was crossed over. In that case, we've got to be given the idea of the structure that we're interested in. You can provide any of the optional filters, and the system will come back then with how many times that was crossed, as well as giving you the opportunity to get many details about the actual permits that were involved in those crossings. We can do the exact same thing for bridges crossed under. Same requirements where we have the need for a specific bridge ID. We can ask for the number of times that a specific route segment was traveled, involved in the overall permit trip. With that, we need to know the details about the segment that you're interested in, what route, what county, what range along that roadway that we're going to return the information for. And again, all those optional parameters that can be provided. We'll provide back the counts for that specific segment. One of the interesting things here is that we may or may not include bidirectional information depending on the request. You can say I want to go from point 1 to 2 here. We may show it one way. We can show both directions travel depending on what is being requested. Now, those first 3 showed a number of times for a specific, I'll say, asset, part of the road, a specific bridge. The last 3 are similar to the first, but it's times that every single asset was involved. So we can show the times for all bridges that were crossed over, for all bridges that were crossed under, and for each roadway segment that was traveled. For those 3 cases, we don't have to provide any specific identifiers or anything. We're doing it for the entire collection of assets that are represented in the system, though you can go then and provide any other query criteria. Okay. For the filtering, so we have the 6 types of queries, and any of them can be filtered by many different parameters. We can go and filter for specific permits if we so choose. We can filter for validity ranges for the permits from a specific start date to an end date, from both in between both of those. Filter based on a permit type. Filtering based on company, the applicant, carrying company, or permit service. We can go and filter based on many different aspects of the vehicle itself, from type of load to a specific vehicle based on some identification, to any one of a number of dimensions and weights, and whether you want to be greater than, or just show me the ones that are less than a certain weight, or show me between these weights. All of those are possible. And then the last main thing that we do is work with filtering from a specific origin or to a specific destination. Okay, what we'll see, and I'm going to run through a full demonstration to show the whole process in execution, but just a couple more screens here to look at the details of what's happening. On the map pane, we're going to see color-coded, or somebody may say a heat map or thematic results of what happens from our query, the results of our query. And in this one, this is route segment based. We're able to zoom in, get more details as we go along, and work with all the different types of map layers that we have, as well as getting details about any one item very dynamically with the different ranges and different coloration heat mapping that we're going to use for the visualization. We're able to go and work by default with setting up the ranges in what we call linear mode. And in that linear mode, we take the maximum count or frequency that we have and evenly distribute those across 10 different ranges. We can also go and use what we refer to as kind of an exponential range, where we try and divide our occurrences evenly. So if based on the total number of bridges here, in this case, a bridge was used a maximum of just over 2,500 times, but we're showing not quite 2,300 bridges. So we try and get those 2,300 bridges evenly split along the ranges so that we don't have one bridge in this count and then 2,200 that are all brown necessarily. Real even distribution. All of the color coding, colors can also be selected. You've got total control of what you're seeing. And just examples of what these legending options allow us to do. In this default linear setup, we'd see a map something like that. And we try to make it so that the highest used asset is always drawn on the top. So all of our brown, those highest level occurrences, will appear on top of any of the darker greens. If we go and filter this to say, just show me the places where we had at least 200 crossings, we go and filter out a lot of the coloration on the map. We see those areas where we had higher usage up to the maximum frequency. And again, when we drew the first picture, it was drawn about 2,300 bridges. When we filtered to just those bridges that were crossed at least 200 times, we're down to displaying 519 bridges on this map. Going back to no filtering based on frequency, but using the exponential visualization, we see slightly different coloration. A lot more in a higher frequency, fewer in that lower band. Really, it's because we're more evenly distributing all the bridges that we're going to display. And then again, if we go and filter out just based on 200 crossings or more, what that does is, if you look here through the legend, 200 crossings is way in this range here. So these are only the ones that we're going to show. But again, it's an equal distribution of the elements across those ranges. Okay. When we have results, our data can be saved. We can go and say export to Excel, and we're going to be able to take all of this information, export it out. You may want to use that and integrate this with some other tools that you have inside the agency, so all of that data is available. You can map it another way. You can integrate it with a different database or whatever you would want to choose to do that way. And when we have a query where we're looking at one of the three numbers of times for a specific bridge or specific roadway segment, we have the option to look at permit details. So we can go and say, for all of those crossings of that specific bridge, show me the specific permit details. And I've blurred out some of the real identifying characteristics again, but for this specific bridge, we've got all kinds of results here where these are permits that were actually involved in that crossing. And the permit IDs are hyperlinks. We can go and actually look at a copy of the permit document. So we have a whole lot of power here in bringing all of this data together, taking it all the way back to see the permit that was originally issued. Now, the last things here, just before we get into actually allowing the whole process, showing the whole process, is the origin and destination filters. And I'll show an example as we go through demonstration, but this can be a little bit complex to think about, but with an understanding of it, again, you see how powerful this can be. If we go and put in a value for the trip from, we will filter our results so it just looks at those permits that started at that specific point, and then we'll be mapping out and showing the tabular results for all the trips that started from there and branched out to wherever it may have been. If we enter in just a trip to, we'll go and isolate to those trips ending at a specific point, and we'll see all of where they came from. If we would choose to go and enter in a trip from and a trip to, then our results are going to be filtered to only show the trips, the segment usage, the bridge usage from the defined origin to the defined destination. Again, when we get combining these filtering capabilities or filtering criteria, the possibilities are almost infinite in what you can be looking at in the data for everything that's been permitted. We see so many different uses in this. It can be very valuable for you just to understand overall where your loads are going, get some movement tendencies, maybe used for enforcement. A lot of the movement tendencies can help with transportation improvement planning. We know money is tight everywhere. Our infrastructure needs work, though. And so you can see where the loads are going and make sure that that infrastructure is well maintained. You may also be able to see and find this very, very visually that we've got an interstate roadway that should be where we want to have these loads going, but we are routing around one specific structure. And we may be routing around because it's low, because it's weak, whatever the condition may be. And if that one specific structure was improved, we may save carriers a whole big distance of detouring, give them a more direct route, keep them off a lower level roadway, whatever the condition is there. But you will have very specific data that says, hey, executive management, I know there was 2,182 specific moves were affected last year because of this bridge. And that becomes just so powerful and valuable. We also have vision here that this is going to help with freight corridor management and planning. Some of those last things that I just showed there with the to and from kind of filtering allows you to do that. And based on your specific jobs, I'm sure there are so many other things that you can come up with that would be impacted by this. Just one sidebar also, for those of you that know and understand about the permitting and routing, we have a relatively new aspect to the permit alert that uses a lot of this kind of data to look at all those permits that are outstanding and to actively notify those permit holders if something changes to the infrastructure, to that trip that they had since the time that they were issued the permit, but before the permit expires. So a whole lot going in here with this kind of data. Okay, I'm going to flip over right now. We've got a demonstration here. We recorded it over the last couple weeks here, and I can provide this separately as well as we'll have the whole webinar here. Based on how we're doing this right now, I will speak over everything that you're seeing. So for the Route Data Miner here, everything is launched in the admin area. You select the Route Data Miner tool. It pops up our tri-view mode, the results, or the query window, the results window, both map and tabular data. We'll go and select one of the 6 options. You can see all the different types of options that we had mentioned in the presentation there. The 3 that are the specific times that an element is used, that an asset's used, and then the 3 on the bottom that are the number of times that the entire inventory is used. We'll go ahead and we'll start off doing a query here with the number of times that every bridge is crossed over, and have the ability to filter down any of the values as I showed on the 4 or 5 different panes there for the elements that we can go and use to limit what we're seeing in our overall output results. You see all these sections are collapsible, just helps us see and understand what we're working with a little bit easier. A pretty dynamic pane there. So we'll start off with the number of times each bridge is crossed. For our example, we're going to go and, as I mentioned, limit our range to January of 2017. So we're going permits valid from 1/1 to 1/31. And we'll go ahead then and request that query be executed. Most of the time, it takes only a couple seconds. We've got our results, and we see every single bridge ID and the frequencies that those bridges were crossed. By default, we start showing the most frequently crossed at the top. Any of this sorts can be changed. And we can then go ahead and show that on the map. So just as we saw in a couple of sample slides, everything's shown graphically, the heat map, thematic, whatever you want to use terminology-wise for that. There's our legend. And we talked about the way that we can go and control exactly what's being shown and how it's being shown. So we're seeing all 2,500 are the frequencies that range from 1 to 2,500 plus times. We've got all of the different color coding with each range that's there. And I mentioned in the first few slides the legend capabilities are really just defaults with the linear and exponential. You can go at any time and also change those range values to be anything that you want. The more we zoom in, the more detail we're able to see. We support all the different map background layers that we have with the overall permitting and routing process, satellite imagery, a couple different options for different color coding, and then some of the high contrast that can make some of these graphics pop, as well as assist if there's any kind of vision, color blindness issues that may exist. When we're zoomed in, we can hover over anything that's shown, and we see the tooltips. This tooltip for the bridges just shows the bridge ID and its frequency, its usage value. So that bridge being used 7 times, and you can see where those travel patterns are going, have gone, I should say. Here's execution where we go in and filter what we're seeing. So we're going to require that a bridge be crossed at least 20 times before it show up in our results now, and you can see dynamically how much that goes and clears out the map and what we're looking at, and clarity, and helping us to start to depict higher usage areas that aren't necessarily the highest still. We'll go to 200. So here now we filtered this down to crossings of at least 200 times. And the map gets cleaned up even more. You start to really see, have an understanding for a corridor basis where we're really preferring to keep the loads. So we've cleared that back out, reset what we were looking at. And we'll go ahead here. Oops. About that. You can just look at the way that the ranges were for the linear, change to the exponential. We see that it's totally different ranges. Now the dark green is only 1 to 2 occurrences. We're trying to get more even distribution of those bridges rather than of the frequencies. We'll go ahead, apply that, and you'll see the map switch over immediately to the new color coding that's defined by the legend. And you can see a lot of those lower ranges are very, very tight, very small, because we're trying to get those same number of bridges in there. If we go and filter out the results like we did on the other one, we'll see the corridors again. See very few colors shown on the map, and that's because if we look down to our range definitions, that 200 falls, in the pinkish kind of color. There's only 4 ranges or so that are shown on the map, and we're only now representing 520 bridges out of the almost 2,300 that initially qualified. We'll go ahead and reset this. Go back to our linear mode. We're going to look at a few different criteria here that we can work with then to filter our results a different way. The legend was allowing us to filter by changing the minimum number of occurrences that had to happen. Now we'll go and filter based on data, the permit data. And so we're going to ask to see just the loads that exceeded 150,000 pounds. We can see that our counts are much lower. What were they, 2,500-ish before? And now we only had 198 moves, permits, where the vehicle exceeded 150,000 pounds. And we can show that on the map, and we see exactly where those heavier vehicles tended to go. We can make our query a little bit more complex and now limit our range, our weight range, so between 150,000 pounds and 200,000 pounds. And where we had 198 vehicles or so over 150,000 pounds, it's now down to 147 that fell between, those two weights. And we can update the map again and see exactly where those loads have gone. Oh, clear out the top end, and we're going to make our bottom end weight the 200,000 pounds. So now we've got to exceed 200,000 pounds in weight, and we'll make the condition just a little bit more difficult, where it's got to be over 15 feet high. So these conditions are ANDed together. All of the criteria have to hold true to be represented. And so if we look at greater than 200,000 pounds and greater than 15 feet high, we're down to 12 loads. 12 permits. We see where those went, again, graphically, and that picture starts to tell us so much, even though it's only 12 loads. But interestingly, where so many of the other conditions that we see focused around the Baltimore area, a lot of times moving around the outskirts of Baltimore, our deeper colors are now up in the northwest area there, rather than more centralized. Just changed real quick to see another condition, only one criteria, but greater than 15 feet wide, 62 loads, and we see again where our occurrences shift around in the state overall based on that condition. And we can do 15 feet wide and 15 feet high, and again, even more different. We see this a little bit of a corridor from the DC area up to the central Pennsylvania border. So I'm going to go ahead and change the type of query from showing all bridges to just showing a specific bridge being crossed over now. We start to enter the identifier for that bridge, and as we do that, we've got smart type aheads. It's looking at just those IDs that match what I've typed so far. Got my conditions there still, 15 high, 15 wide. We do the search, and we find that that bridge was crossed just one time for the time period that we have, and the 15 high and 15 wide. If we go and remove the conditions and do our search, we'll see that it's been crossed a whole lot more than that for the entire population of permits, and it's over 2,500 times. All the same visualization. We can zoom in, see exactly where that is. What roadway is this involved in? Why do I have trips going here? Is this exactly where we want our travel going? Now, everything that we do ends up showing in the tabular text-based results area as well. I did mention in the opening slides about the permit details. To get those, we would just click on the permit details button. Again, in protecting the innocent here, won't show the actual form with all of the details about those permits, but it's exactly where you do it, and we'd have access to the information on every single one of those moves, the exact vehicle configurations, the exact times, the exact companies, and be able to see full copies of all those permits as well. As with about all of the current permitting and routing implementation, any time that we have tabular results, we're also able to go and export those out to Excel. This specific condition isn't too exciting to export out the two fields, but should we have been looking at one of the other queries where we had a list of 2,000 bridges and their occurrences, you can go and export that out. If we do the queries where we have the roadway segments we'll look at in just a minute here. There's a lot more data there, and that may be something that you want to go and join up with some other agency system, and so there can be some definite value in going and exporting that data out into an Excel spreadsheet and getting it outside of just our solution. Okay, let's go ahead then, and we've been looking at the bridge basis. We'll take a look at some of the roadway segment usage. We'll keep that same January time frame. The roadway segments normally take just a little bit longer to query. There are many, many more road segments than bridges. You can see here there's almost 18,000 segments that came back and met the criteria here that we're working with. We see the usage counts for those, and we can go and draw them on the map the same way. Again, takes just a touch longer to draw these on a map, but this isn't the real time I'm doing this 500 or 1,200 or 1,500 times a day, and as we are in our permit issuance, this is that you're doing once, twice a day, once, twice a month in different type of mining that you're looking at. So still very, very responsive overall on what we're trying to do here. Similar kind of map. You can see that it's a lot denser overall because most of the roadway segments in the state are probably included in a query like this. Where we filtered on dimensional size weights before, we're going to go and filter here now on a specific load description. So we're going to look at just where our mobile equipment cranes are going, and this can be valuable for wind energy or cranes or whatever the condition is that you're interested in. And so what we get back now is just the 44 specifically permitted moves for special mobile equipment crane. We go and highlight that. And again, our usage or difference in usage of the segments shows up very, very clearly versus what the entire population of permits were. There was so much darker coloration around Baltimore, and now we see a lot more density or deeper colors around the Washington, D.C. area and going north from there. If we go ahead and clear out that load description, one of the last things I want to do here is show about filtering on the origin and destination. And so this is some pretty powerful, pretty cool stuff. In the slides, I showed a single point, that we want to start at a single point. Well, here we're going to start from the whole Delaware border. And so we did our query, and now in displaying that, this shows where all the moves came from and went, where the Delaware border was the origin for the permit. Well, we can see how many different places that these loads crossed the state, and then where those loads went. And we can see that there's loads that stopped inside the state, just northwest of Baltimore there. We can see a number of loads that crossed through the state totally and got to the Virginia border, the Pennsylvania border, exactly where these moves are going. Now, we're going to go back to the legend, and if we do a little bit of filtering here, we'll see even some more interesting corridor stuff. So now if we say, show me just the moves that occurred 20 or more times from the Delaware border, where there were all kinds of crossings before, we're now down to a set of about 6 specific crossings. And we can see that the one at the very north end far outweighs the other crossings that were used. We can change that 20 to 50 and update our display, and we'll see that that further goes and refines exactly where these moves went. We see them coming in from the very northeast corner, lots of moves moving around Baltimore then, some extending down to Washington, some going out further west. An interesting thing here is you'll see a couple segments that are just highlighted there as islands. And the reason is that like that green segment there was fed by a couple different border crossings. They each were something less than 50. Maybe they were each 25 times, but then they converged into the one roadway. It then exceeded 50 times, and so we have to show that segment. Real key here is that you have to know and understand what you're doing, why the data would be colored this way, but you can get just great value on exactly what's happened. Last thing, we'll go and filter our destination on Pennsylvania. So now what we have is we've gone and require that the move started at Delaware and ended up at Pennsylvania. So you don't see any of those trips that stopped just northwest of Baltimore that showed up on the map nice and clean. We see a few crossings that were used, and then exactly where the loads traveled up into the Pennsylvania area. So really, really powerful there. We can go and filter this down any more that we'd want to. Show me from Delaware to Pennsylvania where I'm just 15 wide. So a whole lot of power in what we're able to do, how we're able to leverage the information from every permit that was issued, and helping you to see that data and to use that data anywhere else that you may want to.